Arc fault circuit interrupters, commonly known as AFCIs, are not mandated for use on two-wire electrical systems. This stems from the requirements outlined in the National Electrical Code, specifically Section 210.12b. This section stipulates that AFCIs are essential for all 15 amp and 20 amp, 120 volt branch circuits that supply outlets or devices installed in dwelling units, dormitory units, and similar living spaces. However, this requirement is conditional and does not extend to two-wire systems, as these systems inherently lack a ground conductor. The operational principle of AFCIs relies on the presence of a ground conductor to effectively detect arcing faults. AFCIs are designed to monitor the electrical current flowing through a circuit. They achieve this by sensing the current's waveform and comparing it to a baseline waveform expected under normal operating conditions. When an arcing fault occurs, it generates erratic and unpredictable current fluctuations. These fluctuations manifest as distortions in the current waveform, which the AFCI can detect. The AFCI compares the sensed waveform to the established baseline, and if significant deviations are detected, indicating a potential arcing fault, the AFCI promptly trips the circuit, interrupting the flow of electricity. This tripping action effectively cuts off the power supply to the affected circuit, mitigating the risk of fire caused by the arcing fault. In essence, the AFCI functions as a sophisticated monitoring device that actively safeguards against electrical fires by detecting and responding to the unique signatures of arcing faults. The absence of a ground conductor in two-wire systems poses a significant challenge for AFCI functionality. Without a ground, the AFCI cannot reliably detect the telltale signs of arcing faults. The ground conductor serves as a reference point for the AFCI, allowing it to accurately measure the current flow and identify any deviations caused by arcing. In a grounded system, when an arcing fault occurs, a portion of the fault current will typically flow through the ground conductor back to the source. This ground fault current creates an imbalance between the current flowing through the hot and neutral conductors, which the AFCI can detect. The AFCI is designed to trip when it senses this imbalance, effectively shutting down the circuit and preventing further damage or fire. However, in a two-wire system without a ground conductor, there is no alternative path for the fault current to flow back to the source. As a result, the AFCI cannot detect the imbalance and will not trip, rendering it effective in preventing fires caused by arcing faults. This limitation is precisely why the National Electrical Code does not mandate the use of AFCIs in two-wire systems. It's important to note that while AFCIs are not required in two-wire systems, there are other safety measures that can be implemented to enhance electrical safety in older homes without grounded wiring. One such measure is the installation of ground fault circuit interrupters, also known as GFCIs. GFCIs are designed to protect against electrical shock by detecting ground faults, which occur when current leaks to ground. GFCIs are particularly effective in areas where there is a high risk of moisture, such as bathrooms, kitchens, and outdoor locations. When a ground fault occurs, the GFCI quickly trips the circuit, interrupting the flow of electricity and preventing electrical shock. GFCIs work by monitoring the current balance between the hot and neutral conductors. In a properly functioning circuit, the current flowing through the hot conductor should be equal to the current flowing through the neutral conductor. However, when a ground fault occurs, a portion of the current will leak to ground, creating an imbalance between the hot and neutral conductors. The GFCI is designed to detect this imbalance and trip the circuit when it exceeds a predetermined threshold, typically 5 mA. This rapid tripping action prevents dangerous electrical shocks. Another safety measure to consider is upgrading the wiring in the home to include a ground conductor. While this can be a more extensive and costly undertaking, it significantly enhances the overall safety of the electrical system. Adding a ground conductor provides a path for fault current to flow back to the source, allowing both AFCIs and GFCIs to function properly and protect against both arcing faults and ground faults. When upgrading the wiring, it is essential to ensure that all electrical outlets and devices are also properly grounded. This means replacing any ungrounded outlets with grounded outlets and connecting the ground wire to the grounding system. It is also important to ensure that the grounding system is properly installed and connected to the electrical panel and grounding electrode system. In summary, while arc fault circuit interrupters are not typically required on two-wire systems due to the absence of a ground conductor, it is crucial to consider other safety measures to protect against electrical hazards in older homes without grounded wiring. Ground fault circuit interrupters can provide valuable protection against electrical shock, and upgrading the wiring to include a ground conductor can significantly enhance the overall safety of the electrical system. Remember to always consult with a qualified electrician for guidance on the best safety solutions for a specific home and electrical system. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and published by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is widely adopted by states and local jurisdictions as the basis for their electrical codes, ensuring consistent and safe electrical installations across the country. The purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. The NEC provides detailed requirements for the design, installation, and maintenance of electrical systems, ensuring that they are safe and reliable. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 covers general requirements such as definitions, wiring methods, and overcurrent protection. Chapter 2 focuses on wiring and protection, including conductor sizing, grounding, and surge protection. Chapter 3 covers wiring methods and materials such as cables, raceways, and enclosures. Chapter 4 addresses equipment for general use, including appliances, lighting, and motors. Chapter 5 covers special occupancies such as hazardous locations, healthcare facilities, and swimming pools. The NEC is a complex and comprehensive document, and it is essential for electricians, contractors, and other electrical professionals to have a thorough understanding of its requirements. The NEC is not intended to be a design manual, but rather a set of minimum safety standards. Electrical professionals are responsible for ensuring that their installations meet or exceed these standards. It is important to consult the latest edition of the NEC for the most up-to-date requirements. The NEC is constantly evolving to keep pace with advancements in electrical technology and safety practices. Regular updates ensure that the code remains relevant and effective in protecting persons and property from electrical hazards. In addition to the NEC, there may be other applicable codes and standards that need to be considered, such as local built-in codes and product safety standards. It is important to be aware of all applicable requirements and to ensure that electrical installations comply with all relevant codes and standards. Compliance with the NEC and other applicable codes and standards is essential for ensuring the safety and reliability of electrical systems. Failure to comply can result in serious consequences, including electrical shock, fire, and property damage. Therefore, it is crucial to hire qualified and experienced electrical professionals who are knowledgeable about the NEC and other applicable codes and standards. These professionals can ensure that electrical installations are performed safely and correctly, minimizing the risk of electrical hazards. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or questions. Working with electricity can be dangerous, and it is essential to take all necessary precautions to ensure safety. Never attempt to perform electrical work if you are not qualified or experienced. Electricity is a powerful force, and it must be treated with respect. By following safety guidelines and consulting with qualified professionals, you can ensure that electrical systems are safe and reliable. Arc faults are dangerous electrical problems that can lead to fires. They occur when electricity jumps from one conductor to another, creating a spark or arc. This arc can generate intense heat, which can ignite nearby flammable materials such as wood, paper, or fabric. Arc faults can be caused by a variety of factors, including damaged wiring, loose connections, and faulty appliances. Damaged wiring can occur due to wear and tear, physical damage, or improper installation. Loose connections can develop over time due to vibration or thermal expansion and contraction. Faulty appliances can have internal wiring problems that can lead to arc faults. There are two main types of arc faults: series arc faults and parallel arc faults. Series arc faults occur in a single conductor, such as a broken wire. Parallel arc faults occur between two conductors, such as a hot wire and a neutral wire. Arc fault circuit interrupters, or AFCIs, are designed to detect arc faults and interrupt the flow of electricity, preventing fires. AFCIs work by monitoring the electrical current and looking for patterns that are characteristic of arc faults. When an AFCI detects an arc fault, it quickly trips the circuit, cutting off the power and preventing a fire. AFCIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. They are particularly important in areas where there is a high risk of fire, such as kitchens and laundry rooms. AFCIs are an important safety device that can help to protect homes and families from the dangers of arc faults. It is important to have AFCIs installed in all required areas of the home and to test them regularly to ensure that they are functioning properly. To test an AFCI, simply press the test button on the device. This should cause the AFCI to trip, cutting off the power to the circuit. If the AFCI does not trip when the test button is pressed, it may be faulty and should be replaced. It is also important to check the wiring in the home regularly for any signs of damage. Damaged wiring should be repaired or replaced by a qualified electrician. By taking these precautions, you can help to prevent arc faults and protect your home from fire. Electrical safety is a serious matter, and it is important to be aware of the dangers of electricity. Always follow safety guidelines and consult with a qualified electrician for any electrical work or questions. The safe and proper functioning of an electrical system is contingent upon multiple factors, one of the most critical being grounding. Grounding, in essence, provides a low resistance path for electrical current to flow back to the source in the event of a fault. This path is vital for preventing electrical shocks, minimizing the risk of fire, and ensuring the proper operation of electrical equipment. Grounding achieves its protective function by creating a direct connection between the electrical system and the earth. This connection is typically established through a grounding electrode, such as a ground rod or a metal water pipe, which is buried in the ground. The grounding electrode provides a low resistance path for fault current to flow to earth, tripping the circuit breaker or fuse and interrupting the flow of electricity. Without proper grounding, fault current may find alternative paths to ground, such as through a person who comes into contact with an energized object. This can result in a severe electrical shock or even electrocution. Grounding also helps to prevent the buildup of static electricity, which can damage sensitive electronic equipment. Static electricity can accumulate on surfaces due to friction or other factors. When static electricity discharges, it can create a spark that can damage electronic components. Grounding provides a path for static electricity to dissipate safely to earth, preventing damage to equipment. In addition to protecting against electrical shock and equipment damage, grounding also plays a crucial role in minimizing the risk of fire. When a fault occurs, high levels of current can flow through unintended paths, generating heat that can ignite nearby flammable materials. Grounding helps to limit the duration and magnitude of fault current, reducing the risk of fire. There are several different types of grounding systems, each designed for specific applications. The most common type of grounding system is the equipment grounding system, which connects the metal enclosures of electrical equipment to ground. This system helps to prevent electrical shock by providing a low resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse. Another type of grounding system is the system grounding system, which connects the neutral conductor of the electrical system to ground. This system helps to stabilize the voltage of the electrical system and prevent voltage fluctuations. Proper grounding is essential for the safe and reliable operation of electrical systems. It is important to ensure that all electrical equipment is properly grounded and that the grounding system is installed and maintained in accordance with applicable codes and standards. Electrical safety is paramount, and grounding is a critical component of any safe electrical system. Always consult with a qualified electrician for any electrical work or questions. The electrical panel, often called a breaker box or service panel, serves as the central distribution point for electricity within a building. It receives power from the utility company's service entrance and distributes it to various branch circuits throughout the building. The electrical panel houses circuit breakers, which are protective devices that automatically interrupt the flow of electricity in the event of an overload or short circuit. The electrical panel is typically located in a readily accessible area, such as a basement, garage, or utility room. It should be properly labeled to identify the circuits that each breaker controls. This labeling is essential for troubleshooting electrical problems and for safely disconnecting power to specific areas of the building. The electrical panel should be sized appropriately to accommodate the electrical load of the building. The electrical load is the total amount of power that is consumed by all of the electrical devices and appliances in the building. The electrical panel should have sufficient capacity to handle the maximum electrical load without overloading. Overloading an electrical panel can cause the circuit breakers to trip frequently, which can be inconvenient and potentially dangerous. In severe cases, overloading can lead to overheating and fires. It is important to have a qualified electrician inspect the electrical panel periodically to ensure that it is in good condition and that it is properly sized for the electrical load. The electrician can also check for any signs of damage or wear and tear, and make any necessary repairs or replacements. The electrical panel should be kept clean and free of obstructions. Do not store anything in front of the electrical panel that could block access to it. In the event of an electrical emergency, it is important to be able to quickly and easily access the electrical panel to disconnect power. Never attempt to repair or modify an electrical panel unless you are a qualified electrician. Working with electricity can be dangerous, and it is essential to take all necessary precautions to ensure safety. Always disconnect power to the electrical panel before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. The electrical panel is an important component of the electrical system, and it is essential to maintain it properly. Regular inspections and maintenance can help to ensure that the electrical panel is safe and reliable. The role of a qualified electrician is indispensable when dealing with electrical systems. Electricians possess the knowledge, skills, and experience necessary to safely and effectively install, maintain, and repair electrical systems in residential, commercial, and industrial settings. Their expertise encompasses a wide range of tasks, from wiring new buildings to troubleshooting electrical problems to ensuring compliance with electrical codes and standards. Electricians undergo extensive training and apprenticeship programs to develop their expertise. They learn about electrical theory, wiring methods, safety practices, and the National Electrical Code. They also gain hands-on experience working under the supervision of experienced electricians. Qualified electricians are licensed by state or local authorities, which ensures that they have met certain minimum standards of competency. Licensing requirements typically include passing an examination and completing a certain number of hours of experience. When hiring an electrician, it is important to verify their license and insurance. This will protect you from liability in case of accidents or damage. Electricians can perform a wide variety of electrical services, including installing wiring outlets and lighting fixtures, troubleshooting electrical problems, repairing electrical equipment, and upgrading electrical panels. They can also perform electrical inspections to ensure that electrical systems are safe and compliant with codes. Electrical work can be dangerous, and it is essential to hire a qualified electrician to do the work. Electricians have the training and experience necessary to work safely with electricity and to ensure that electrical systems are installed and maintained properly. Attempting to do electrical work yourself can be risky and can lead to serious injuries or even death. It is always best to leave electrical work to the professionals. When hiring an electrician, it is important to get a written estimate before the work begins. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. It is also important to ask the electrician about their experience and qualifications. Choose an electrician who is experienced in the type of work that you need to have done and who has a good reputation. A reputable electrician will be honest and reliable and will stand behind their work. Electrical safety should always be a top priority. By hiring a qualified electrician, you can ensure that your electrical systems are safe and reliable. Electrical systems are designed to operate within specific voltage ranges. Voltage is the electrical potential difference between 2 points in a circuit. It is the driving force that causes electric current to flow. In residential electrical systems in the United States, the most common voltage is 120 volts. This voltage is used to power most household appliances and lighting fixtures. Some larger appliances, such as electric stoves, clothes dryers, and air conditioners, require 240 volts. Commercial and industrial electrical systems may use higher voltages, such as 208 volts, 277 volts, 480 volts, and even higher. These higher voltages are used to power large motors, machinery, and lighting systems. The voltage of an electrical system is determined by the utility company that provides the power. The utility company must ensure that the voltage is maintained within a certain range to prevent damage to electrical equipment. If the voltage is too low, electrical equipment may not operate properly. If the voltage is too high, electrical equipment can be damaged or even destroyed. Electrical equipment is designed to operate within a specific voltage range. It is important to ensure that the voltage of the electrical system is compatible with the voltage requirements of the equipment. Using equipment that is not designed for the voltage of the electrical system can be dangerous and can lead to equipment failure or even fire. The voltage of an electrical system can be measured with a voltmeter. A voltmeter is an instrument that measures the electrical potential difference between 2 points. To measure the voltage of a circuit, connect the voltmeter to the 2 points that you want to measure. The voltmeter will display the voltage reading on its screen. It is important to use a voltmeter that is designed for the voltage that you are measuring. Using a voltmeter that is not designed for the voltage can be dangerous and can damage the voltmeter. Electrical safety is paramount when working with electrical systems. Always disconnect power to the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Understanding voltage and electrical safety is essential for anyone who works with electrical systems. By following safety guidelines and consulting with qualified professionals, you can ensure that electrical systems are safe and reliable. The selection of circuit breakers for an electrical panel is a critical aspect of electrical system design and safety. Circuit breakers are overcurrent protection devices that automatically interrupt the flow of electricity when a fault or overload condition occurs. They are designed to protect electrical circuits and equipment from damage caused by excessive current. When selecting circuit breakers, it is important to consider several factors, including the amperage rating of the circuit, the voltage rating of the circuit, and the interrupting capacity of the circuit breaker. The amperage rating of the circuit breaker should be equal to or slightly higher than the maximum current that the circuit is expected to carry. This will ensure that the circuit breaker will trip before the circuit is overloaded. The voltage rating of the circuit breaker should be equal to or higher than the voltage of the circuit. This will ensure that the circuit breaker can safely interrupt the flow of electricity at the rated voltage. The interrupting capacity of the circuit breaker is the maximum amount of current that the circuit breaker can safely interrupt. The interrupting capacity should be high enough to handle the maximum fault current that the circuit is likely to experience. In addition to these basic considerations, there are other factors to consider when selecting circuit breakers, such as the type of load that the circuit will be serving, the environmental conditions in which the circuit breaker will be installed, and the specific requirements of the electrical code. There are several different types of circuit breakers available, each designed for specific applications. The most common types of circuit breakers include thermal magnetic circuit breakers, magnetic-only circuit breakers, and electronic trip circuit breakers. Thermal magnetic circuit breakers are the most common type of circuit breaker and are used in a wide variety of applications. They use a thermal element to detect overloads and a magnetic element to detect short circuits. Magnetic-only circuit breakers are used in applications where fast tripping is required, such as in motor circuits. They use only a magnetic element to detect overcurrents. Electronic trip circuit breakers use electronic components to detect overcurrents and provide advanced protection features, such as ground fault protection and arc fault protection. When selecting circuit breakers, it is important to consult with a qualified electrician to ensure that the correct type and size of circuit breaker is selected for the application. A qualified electrician can assess the electrical load, the circuit characteristics, and the applicable electrical codes to determine the appropriate circuit breaker for the job. Proper circuit breaker selection is essential for ensuring the safety and reliability of an electrical system. By selecting the correct circuit breakers, you can protect electrical circuits and equipment from damage caused by overcurrents and prevent electrical fires. Electrical codes and standards play a crucial role in ensuring the safety and reliability of electrical systems. These codes and standards are developed and maintained by organizations such as the National Fire Protection Association, the Institute of Electrical and Electronics Engineers, and Underwriters Laboratories. Electrical codes and standards provide detailed requirements for the design, installation, and maintenance of electrical systems. They cover a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. The purpose of electrical codes and standards is to safeguard persons and property from hazards arising from the use of electricity. They are based on years of experience and research and are constantly updated to reflect the latest advancements in electrical technology and safety practices. Compliance with electrical codes and standards is essential for ensuring the safety and reliability of electrical systems. Failure to comply can result in serious consequences, including electrical shock, fire, and property damage. Many states and local jurisdictions adopt electrical codes and standards into law. This means that compliance with these codes and standards is mandatory. Electrical inspectors are responsible for enforcing electrical codes and standards. They inspect electrical installations to ensure that they are in compliance with the applicable codes and standards. Electrical inspectors have the authority to issue citations and require corrections if electrical installations are not in compliance with codes. Electrical codes and standards are not static documents. They are constantly evolving to keep pace with advancements in electrical technology and safety practices. Regular updates ensure that the codes and standards remain relevant and effective in protecting persons and property from electrical hazards. It is important for electricians, contractors, and other electrical professionals to stay up to date on the latest electrical codes and standards. This can be achieved by attending training courses, reading industry publications, and participating in professional organizations. Electrical codes and standards are essential for ensuring the safety and reliability of electrical systems. By complying with these codes and standards, you can help to protect yourself, your family, and your property from electrical hazards. Upgrading an electrical panel is a significant undertaking that can improve the safety and reliability of an electrical system. An electrical panel upgrade involves replacing the existing electrical panel with a new, larger panel that can handle a greater electrical load. There are several reasons why you might need to upgrade your electrical panel. One reason is that your existing panel may be too small to handle the electrical load of your home. This can happen if you have added new appliances or electrical devices to your home over time, or if you are planning to add new additions or renovations that will increase the electrical load. Another reason to upgrade your electrical panel is that your existing panel may be old or outdated. Old electrical panels can become corroded or damaged over time, which can increase the risk of electrical fires. Outdated electrical panels may also lack modern safety features, such as arc fault circuit interrupters or ground fault circuit interrupters. When upgrading an electrical panel, it is important to hire a qualified electrician to do the work. An electrical panel upgrade involves working with live electrical wires, which can be dangerous if not handled properly. A qualified electrician will have the training and experience necessary to safely and effectively upgrade your electrical panel. The electrician will first assess the electrical load of your home to determine the appropriate size of the new electrical panel. They will then disconnect power to the existing electrical panel and remove it from the wall. The electrician will then install the new electrical panel and connect the electrical wires to the new panel. Once the new panel is installed, the electrician will test the circuits to ensure that they are working properly. An electrical panel upgrade can be a costly project, but it is an investment that can improve the safety and reliability of your electrical system. By upgrading your electrical panel, you can ensure that your home is protected from electrical hazards and that your electrical system is able to handle the electrical load of your home. When dealing with older homes, it is important to be aware of the potential for electrical hazards. Older homes may have outdated wiring, undersized electrical panels, and a lack of modern safety features. Outdated wiring can become brittle and cracked over time, which can increase the risk of electrical fires. Undersized electrical panels may not be able to handle the electrical load of modern appliances and devices, which can lead to overloaded circuits and trip breakers. A lack of modern safety features, such as arc fault circuit interrupters and ground fault circuit interrupters, can increase the risk of electrical shock and fire. If you own an older home, it is important to have a qualified electrician inspect your electrical system to identify any potential hazards. The electrician can assess the condition of the wiring, the size of the electrical panel, and the presence of safety features. Based on the inspection, the electrician can recommend any necessary repairs or upgrades to improve the safety of your electrical system. Some common electrical upgrades for older homes include replacing outdated wiring, upgrading the electrical panel, and installing arc fault circuit interrupters and ground fault circuit interrupters. Replacing outdated wiring can improve the safety and reliability of your electrical system and reduce the risk of electrical fires. Upgrading the electrical panel can ensure that your electrical system is able to handle the electrical load of modern appliances and devices. Installing arc fault circuit interrupters and ground fault circuit interrupters can protect against electrical shock and fire. When making electrical upgrades to an older home, it is important to comply with all applicable electrical codes and standards. This will ensure that the upgrades are performed safely and correctly and that the electrical system is in compliance with the latest safety regulations. Electrical safety is paramount in older homes. By having a qualified electrician inspect your electrical system and making any necessary repairs or upgrades, you can protect yourself, your family, and your property from electrical hazards.